From last day, we studied the following equation for annuities. Remember, annuities were regular payments over a certain amount of time, or yeah, that was pretty much it. So basically our equation was just FV is equal to R 1 plus I to the n minus 1 n bracket divided by, remember, our I value has to be in a bracket. So for this problem, what we're going to be doing is we're going to be taking a look at our original equation, and we're going to use our original equation to find certain values. Now, this one I want you to write really small, so we're going to start off by taking a look at this problem, and we're going to analyze everything that we want. So Bill wants to have $4,000 in 2 years. So anything that is in the future is what we call the future value. So I'm actually going to write on here FV for future value. Now, for a college program, what monthly deposit is required if the interest rate is 4.2%? Now, because it's 4.2%, I'm always going to sit down and I'm going to make sure I get it right. So I go 4.2 divided by 100, you get 0.042 as my value. So now what we're going to do is we're going to take our moment, we're going to take a few minutes, and we're going to work through this problem. We start by writing our equation as usual. FV is equal to R bracket 1 plus I to the n minus 1 divided by I. Now, hold on until I finish the entire note, and then if you have to, review the note by listening to it again and taking a look at your problems to see if you have any issues. Now, we're going to do our substitution. So now FV is 4,000. We said the R value, oh my God, there's no R value, so we're just going to leave the R value as big R. We're going to put our substitutions in. So we get 1 plus 0.042 divided by, now it's compounded monthly, so anything that's compounded monthly means it's 12. So we're dividing by 12 and raising to 2 years. 2 times 12 is 24. So that's what n is, 24. And then we divide by 0.042 divided by 12. Now, on your calculator, we're going to save ourselves some time. What we're going to do is we're going to calculate this. Bracket 1 plus 0.042 divided by 12, bracket raised to the 24, and then we're going to subtract 1, end bracket. And then immediately upon calculating that, we divide by this, divide by bracket 0.042 divided by 12, end bracket. By doing so, we end up having R is times by some ugly number, 24.99125. Notice the ... I usually go to about 5 or 6 digits when I'm calculating those values that are going to be sitting beside R in these calculations. So now we have 4,000 equal to R times this. So in our problem here, the steps that we have followed so far, we filled in all the info. So this part here was number 1. We simplified all the numbers on the right side. So this part here is what we were talking about for number 2. This is number 2. So it's kind of like you basically take all these numbers here by simplifying. We really mean calculate this and divide by this and then put it beside the R value. And that's what this part represents. Finally, to solve for r, we're going to divide both sides by this thing. So we're going to get r, in this case, is equal to 4,000 divided by 24.99125 ... And when we do our final calculation, r is equal to 160.06. Now going back to our algorithm for this and solve r by dividing, so this part here is number 3. So these are the 3 steps that you need in order to get what we're looking for, which is our final answer here. R is 106.06. So now I'm just going to quickly write the final concluding sentence. His monthly deposit. Notice when I respond with my final sentence, I always want to refer to what we were looking for. In this case, our original problem asked for what was the monthly deposit required, and that is what we're going to answer. The monthly deposit will be 160.06. Now we'll move on to our second problem of the day. On your 18th birthday, you decide to start saving for retirement at the age of 60. You want to have $500,000. You estimate the interest will average 5.5% monthly. What monthly deposit's required? Let's follow the same steps that we did before. Remember, our equation always has to be written. So we've got FV is equal to, for an annuity, it's R bracket 1 plus I to the n minus 1 divided by I. So let's go and identify all of the values that we have in this problem. It says on our 18th birthday, we're going to, we're going to 60. So in order to figure this out, the number of years is equal to 60, which is our last year, minus our first year, which is 18. So that means we have 42 years of work to do. So now that we've got our 42 years of work, what we're going to do is we're going to figure out that we want to have 500,000. So that means this part here, our 500,000, represents our future value. And its compounding interest rate is going to be, well, we're going to change that into 5.5%. And now we'll do our basic substitution. So let's go through this. So our future value is 500,000. 1, 2, 3, 4. Yeah. So that's 500,000. Our R value we're looking for, because that's where we're asking for our monthly deposit. Oh, and it just told us what our compounding number. Because it's monthly, the compounding number is equal to 12. So now let's do our substitution. So 1 plus, well, I is 0.055 divided by, now the compounding number is 12, so I'm just going to emphasize that in red for you. And then we're raising it to, well, 504. Now, how did I get 504? 504 comes from 42 times 12. That's where we get that. And then we subtract 1 as before and divide by bracket 0.055. And just like before, I'm going to emphasize my compounding number of 12. Now, all we have to do now is punch this bit into our calculator divided by this bit. So we just follow bracket bracket 1 plus 0.055 divided by 12 end bracket raised to the 5.04 minus 1 end bracket, and then divide by bracket 0.055 divided by 12 end bracket. Hit equals, and you're going to get the following value for R. So R is going to have beside it 1968.3045, and we have 500,000 on the right side. So now, remember, step 1. So this was step 1. Substitute accordingly. Step 2. Simplify all the stuff on the right side. So that was step 2. Step 3. We take R. We get R by itself by doing 500,000. And we divide by 1968.3045. So that is what we get for our R value. And our R value in the end is 254.03. So now we just have to answer our final statement. Now, the final problem that we have here is contributions. So I'm actually going to block this off. We're going to do a quick little mini lesson. Contributions really mean how much money did you actually put in over all of those years, right? Now, if you remember, the number of payments was 504. Now, a contribution, remember what I said earlier, was a contribution was how much money did you pay over the time. So I'm going to call this contributions, also known as contrib, is equal to the payment times the number of times, or the number of payments. So in this case, we just paid 504. We did it 504 times, and our pay that we make each month is 254.03. All right, times that by 504. And what that tells us is that we totally put in this complete amount of money, $128,031.12, and that is our contribution. And now that is our contribution. So you're going to have problems where they're going to ask you for the contribution or the interest. See how the contribution fits in with the interest, but that is basically how we calculate the contribution. So, final answer for this problem is he contributes $128,031.12. Your homework is going to be pushed up on the internet. As well, you have these questions. Page 212, number 5, 8, 11, 19, and 21. Your teacher will probably give you package 211 through 214. So that should be able to cover all the questions you have to do. Good luck.